Okay, so here we are with the final unit. Woo! This is Unit 12, and we're going to take a look at, in this unit, what's called nuclear chemistry. First, you're going to notice some of the vocabulary. Not every single one of these do you need to really know the definition for. Things like alpha particle, beta particle, positron. It's not really a definition. You really should just be familiar with the properties of those specific particles, including gamma radiation. You should definitely know the definition for both fission and fusion, and transmutation. Um, Artificial transmutation, you don't necessarily know the definition for artificial transmutation, but you should know the term transmutation and what that means. Here are the objectives. This is what you should be able to do at the end of the unit. If you can do these things, you should do fairly well. This is sort of a bad joke. All right, so what exactly is nuclear chemistry? Well, nuclear chemistry, as the name implies, is the study of the reactions that are caused by a change in the nucleus of an atom. And what happens is that one atom actually becomes another atom. Now, you should be able to understand the difference between a nuclear reaction, which is what we're talking about in this unit, and a chemical reaction, which is what we've done up until now in the course. A chemical reaction involves only the electrons. So if you look at this model of the atom, chemical reactions involve only electrons, and mainly the valence electrons, which are the electrons furthest away from the nucleus. Nuclear reactions, as you can see here, involve not the electrons, but the nucleus, which is this center part here, which is composed of both the protons and the neutrons. And remember that the neutrons and the protons collectively are called the nucleons, and nucleons are particles that are found in the nucleus. Now, what exactly are we talking about here? What makes an element radioactive? Well, what makes an element radioactive has to do with the nucleus, the stability of its nucleus. Generally speaking, large atoms, meaning elements that have an atomic number of 83 or greater than 83, are naturally radioactive, meaning that their nucleus is unstable. What does it mean when we say that a nucleus of an atom is unstable? It doesn't like the ratio of protons to neutrons. It's a little bit off. Let's break that down into a couple of different things. Well, what about if we're looking at small atoms? Well, if the atomic number is less than 83, the nucleus is generally going to be stable, meaning that they are not radioactive. Here's the exception to this rule. When you're looking at small atoms, in other words, atoms with atomic numbers less than 83, if the mass that is given is not the mass that's on the periodic table, probably a good chance that that atom is going to be radioactive or unstable. Here's a couple of good examples. If you look at your periodic table, the mass on the periodic table for carbon is 12. But there are two isotopes of carbon which are slightly heavier. Carbon with a mass of 13, carbon with a mass of 14. These both happen to be radioactive. These are not the masses on the periodic table. That's one way of telling if an atom is going to be radioactive or not. So generally speaking, an atom with an atomic number above 83 is going to be radioactive. If it's below 83, the way that you can tell is called the exception, the small atom rule, or the exception to that rule, is if the mass of that element is not the one that's on the periodic table, it's going to be radioactive or unstable. Here is, and this is something you can really get from the periodic table. Let's try a couple of examples. And now, for some reason, my pen is not working, so I'm going to quickly run through this. If you take a look at calcium on the periodic table, its mass on the table is 40, which makes this isotope is going to be unstable. Hydrogen's mass on the table is 1, so it will be stable. Oxygen's mass on the table is 16, so that will also be stable. But notice now there's an isotope of oxygen with a mass of 14. That is not its normal mass, so that would make it an unstable isotope of oxygen, meaning it is radioactive. And I believe, let me check my periodic table quickly, that for 93, neptunium, that is the mass that's on the periodic table. But remember, this is atomic number above 83, so this is going to be naturally radioactive. So the mass is 237, but this is going to be unstable because it is above number 83, atomic number 83. So what actually happens to a substance with an unstable nucleus? Well, because the nucleus is not happy with the ratio of protons to neutrons, it is going to go through something called decay. In other words, in order to become more stable, it's going to emit particles from the nucleus, protons and neutrons, until it's happy with the ratio of those two particles. The particles that it gives off in order to become stable would be considered radiation. So radiation really is particles that are given off by an unstable nucleus. It doesn't have to necessarily be particles. It could be what we call gamma rays, which we will talk about also. And that's sort of the introduction to this unit, and that'll be it for lesson 1.